Hello everyone, today we are going to start the part 1 of the static and dynamic analysis of the building. So in this part we will going to see the terminologies which we are going to use for static and dynamic analysis. So these are all the options in the ETABS that we're going to need for the analysis. So as you can see, the first topic and option is the mass source, which need to be defined, and it has to be defined in the various forms, but we will going to define as a specified load patterns. So if we go by load option, when you select this option, only selected load patterns are considered for calculations of mass of structure. It's the best way to define, and IS 1893-2016 specifies to consider 100% dead load along with the 25% live load when your live load doesn't exceed 3 kN per meter square. When live load exceeds 3, then the mass source will be 100% dead load plus 50% live load. Now this is the option for dynamic analysis, that is response spectrum analysis, which we are going to do. So that I will show you in the part 2 how to define this response spectrum function and how to add the in load case. Also ultimately one model load case will be default there because response spectrum is based on model superposition. As you can see, there are different model combination method. Their description also they have given. Also there is different directional combination types which you can study in depth for better understanding. So these are all the different methods which contributes to find the maximum response in the respective directions. And so these are other options associated with that, like modal damping, diaphragm eccentricity. So you can just read these all descriptions of the respective topic in the search. So it will very better to understand when we'll do the actual analysis. As I have mentioned, the model case type is important, which categorize in eigen and Reed's vector analysis. So this is also the one way to find any error in the model and gain some insights into its behavior. So as you can see, the respective descriptions they have given means which method and which analysis option need to choose depends on the behavior and the structural requirements. So these are the detailed options available when you select example eigen or Reed's vector. For Reed's vector they have given these are the configurations. Before putting any value or doing any configuration or customize, you have to know this all menu options and their description. So these detailed options like load type, load name, target mass, participant ratio, percentage, static correction, these all the options are available in the ETABS while doing the analysis. And you have to see some other parameters also, like here they have mentioned maximum number of modes which need to be considered. So again the respective configuration based on the analysis options and parameters will come. Now we'll see the diaphragm, which is the most important part in lateral analysis because which also plays a role in transferring the loads to the components of the structure. So there are mostly two diaphragms, rigid and semi-rigid diaphragms. So I'm just showing one example. Like before starting the analysis, static or dynamic, you should define the diaphragm and assign to the shell. You can define different diaphragms for different floor, or you can also define one diaphragm and you can assign to all the floors or shells. So you can select each and every floor and just assign the diaphragms. You can see the the center of the shell will represent. So here are the options. You can modify the diaphragms. Also you can assign or delete the existing diaphragms properties. So diaphragm need to assign in both earthquake and wind forces, because it will transfer the lateral forces to the vertical elements which are connected to it. So the purpose of diaphragm is to show also center of mass, also to apply wind pressure while diaphragm exposures. So that's why it's also the important parameter in lateral analysis. So thank you. So this is about today. So we'll be moving to part 2. So kindly watch that video as well. Thank you.